1 second.
Mhm.
The legs are so chunky.
Andrew loves the babies.
Yeah.
Oh, here we go. Stand up.
Okay, you ready?
Yeah, I'm ready.
Okay, cool.
Oh.
I did all the assignments, but I have a question in let me
Yes.
in question. I don't remember what is the question. It's in the first
Part one.
in question 3. The
Okay.
B letter B. I don't know why, but I
Yes.
can't do that.
The 40th percentile.
Oh. I'm not on the right one.
No.
Okay, I'm like, what?
Okay. So Daniela, you have to use the standardization in the applet. You have the applet open?
Yeah.
Okay, so unclick everything. So just make the left side blue, the small side.
The what?
Make the small side of it blue. What's on the left? And then the middle section should be clear, and so should the right section. So that means it's only going to shade under 40%.
Oh, see. So the area needs to be. Bueno.
It won't say anything for area yet until you put in 0.4.
Yeah.
When you do that, what does it stand for B for?
0.4. Give me a minute. 4. I have this score is 0.253.
Perfect.
Is it negative?
It's negative, and positive in the other side.
Yeah, so you just want the one on the left side. That's the one you're worried about. So that tells you, so you know what the standard deviation is? It's like a certain percentage away from the median or the middle, the mean. So that is what you're going to use to help you figure out. So that tells you it's 0.2 or 253 of the standard deviation away from 10. Does that make sense?
Oh, yeah.
Yeah. So if the standard deviation that they tell you on the question, if it's 5, if it's 5, then one standard deviation away from 10 is 5.
5.
Does that make sense?
Yeah.
So then if the standard deviation on the applet said -1, then your percentile would be 5. Or I mean, not your percentile, your percentage.
Will be 5. Right. Yeah, I got it. Yeah.
So if you use that number, so you take 10, which is the mean, and then you're going to subtract the standard deviation according to the z-score. So it's 10 minus 5 times negative 0.253.
Negative 2.253 equals x minus 10 over 5.
Okay.
So when you bring it out, let's see if you can. I'm going to turn this so you can see the.
Yeah.
Just turn it on mute so that it doesn't get crazy.
Yeah.
So he's gonna show you what, because I have a whiteboard to write down.
Whoa. Oh, you want to go hang out with mom? That's it. Oh, no, that's crazy. Okay.
You see that?
So point.
You don't need to show you on.
Oh, okay. So X is the number you're trying to figure out.
Give me a minute.
So when you look at Andrew's,
I'm gonna talk. Oh, my microphone's muted. Does that work now? Does this switch to mine?
Oh, okay. I need to. How do you say despejar in English? Yeah, I got it. How do you say
To move to the
to move X? In Spanish, we say despejar.
To move the X?
No sé cómo se diga.
Well, I don't know if you move the X yet. You need to move the 5.
like to move to the other side.
Like it's when you move X to the other side.
yeah, but first you want to multiply both sides by 5.
Yeah. I got it. But
How do you say?
how do you say that process? What is the name of that process?
Isolate X.
Wait.
Isolate.
Like to make it alone? Yeah, so isolate.
Isolate.
So what's the answer you get?
Give me 100. No, I'm sorry, 100 no. 0.8. I no sé. 0.8. 7333.
So
That's 8.73.
right, so the right answer is 8.733. So did you divide negative 0.253 by 5? Or do you multiply it?
Divide.
So shoot, it's gonna be. Let me see if I can show you my calculator so you can see. Okay, so it's supposed to look like. Can you see that right there? This is what it should be. The z-score. The z-score is negative 0.253, and then you multiply the standard deviation by that, and then you add 10. You add 10 because it's x minus 10. So to get rid of 10, you add it to both sides. Man, that's math and formula would be crazy.
Oh yeah. I got this, but it's my answer of the last one, and it's not correct.
Say something.
How?
There we go.
If we talk, it shows our faces. So, present to everyone? No. 1 second. Oh. Sweet. Okay, show us now.
Yeah.
The calculator?
Yeah. Can you see or not?
11.265.
So that's on the other side of the standard deviation. You see, so yours.
Yeah, she has to take negative 0.253.
So yours is the 60th percentile.
So when you did 5, what did you multiply 5 by what?
By the standard deviation. that I get, like
Did you multiply by
Point
positive or negative? 0.2?
253.
Yeah, so you want negative 0.253.
Because it's
Oh.
below.
Negative. So do it again with negative. Good thing you caught that, because I was like, where? How did you get
Yeah,
that?
standard deviation
Right.
is at 50. And you got it.
Oh yeah,
Okay,
8.735.
awesome.
Perfect.
Okay, let's cruise through these. Okay, so C, well, I guess, oh, is there? Well, let's just start doing part 2 then.
Yeah.
Okay, so suppose, suppose Payer Computing sold an average of 45 P phone. What in the world is this problem? P phones per minute in 2011. They sold 23.
They sold 23,652,000 people in 2001 with a standard deviation of 10.
Jeez.
Okay, that's per, oh my gosh, per minute. And then look their people to sample and forward taken from Norway's history. What is this shape? It's normal.
It's normal. Yeah.
Right, is that because the top is normally distributed?
Yeah.
Yes.
the top is
Normal.
5. We don't finish on doing these homework assignments.
Not these ones. These aren't
The
homework.
5 is also normal, right?
You're
Yeah.
right.
A sample size endpoint is taken from a normally distributed. What is the probability that the observed X is less than 40?
I get 15. ¿Cómo? I got 15.87.
I haven't done it yet.
So I'm not really sure how to do that.
So 40 minus 45 over 10. Standard deviation divided by
You're right.
square root of n.
You're right.
Standard
So-
deviation is 10.
10
10 divided
by
square root of 4.
divided by 2. So 40
So negative
minus
5.
45 all over 5 equals -1. So the net standard deviation. So it's just
Negative 1 according to standard deviation.
so it's
We
negative
need to
the -1.
put that in the app, right?
So it's -1. So it's going to be at the first standard deviation below the mean.
What is the probability then?
So
Oh,
then
yeah.
we go to the area. So then we go to the applet and find it. So it's the first standard deviation. And so it's, yeah, oh, she's a killer. She knows what it is before we even did. 15.87. You did it.
So
Yeah,
it's
Yeah, that,
16%.
Yes. But when it talks about probability, we don't really write in percent. We usually use 0.15.
0.15? Oh, yeah.
Right.
Yeah.
Okay.
is that the answer?
Good question. Let me look at the answer. So answer for 6 is 0.1587.
Okay.
Exact.
We nailed it.
Okay, so then the next one.
Oh, flavor.
Weird at first. I didn't know they were flavored. They're cash though. Okay, so what is the probability that the observed X is greater than 35 and less than 55? So greater, so we could logic this real fast.
Greater than 35 and less
So
than
if the standard deviation is 10,
68.
if the standard, yeah, I think so.
Why is it standard
Well,
deviation?
no, I think it's 2 actually, because it's 45 down
Down to 10.
10, but we have a new standard deviation of 1. Like it's 10 over square root of 4.
But why is it a new standard deviation?
Because it's 10 over the square root of 4. So it's 10 over 5.
Yeah.
So it's 2. So it's 95%.
Yeah.
It's the next standard deviation.
Mhm.
You guys are dumb. I already did this way long ago.
And the next one is the same, I think.
Okay. Let's see.
So a sample size n equals 25. Okay, we'll do this one on the blackboard.
This is 7 or 8?
This is 7. Oh, 8. So
8.
n equals 25. Normally, what is the probability that x is greater than 41 and less than 49? So then we go 41 minus 45 all over 10 over
Negative
5.
Negative 4.
Oh, negative 4 over 2.
2.
Yeah, because it's the square root of 25.
Oh, yeah.
So then it's negative 2. She's so good. She just knows everything. It's negative 2 and 2. So it's the second standard deviation. Like, yeah.
Okay.
Because just listen to me before.
A sample size of 25 is taken from, where's the probability of x is over greater than 50?
So just 50. So 50 minus 45
Over
all over 10 over equals 5 over 2.
which equals 2.5 over the standard deviation. So you're going to be applet.
Yeah, you do. Did you get this one, Daniela?
Yeah, I did, and I think it's 95 for the Z-score, but I don't know if this is correct.
2.
So the z-score is going to be 2.5.
Mm-hmm.
And then it doesn't even want to let me do. Oh, there we go. I see it.
That's 0.6%.
Point 0.6? Oh, 0.6%. Okay. Not 6%. 0.6%. I see what you're saying.
So 8 is 6%?
Yeah, 0.00621.
0.00621 is the probability.
Ah, yeah.
I wish
Uh-huh.
there was a
In
way
9.
I could see one answer.
Okay.
You are in 9, right?
Yeah, we just did 9.
Oh, yeah. Mm-hmm.
Okay.
I got
Did you do 10?
Yeah. Yeah. So it's samples of size n equals 4 are taken from the right. No puedo pronunciar eso. Skewed 2010 P-phone sales data. What is the shape of the distribution of X? Is right skewed the same because the size is not so,
Not 30.
Less than 30.
and also because it's right skewed in
Smart.
the pattern.
You said when you said skewed the first time you said it right.
Skewed.
Skewed.
See, so it's right skewed.
Yes.
And 11 is samples of size, and bueno, it's normal because the sample size is bigger this time.
The term of large number?
So even when it's the size is bigger.
Right. So if the size is big enough, then it makes it normal.
Oh, what's
Yeah.
It's this.
central limits theorem.
Uh-huh. You get 12?
Yeah. Is there a theorem that justifies your answer to question 11? What is the name of the theorem? Is central limit theorem, right?
Gosh. Yep. Perfect.
Size,
No, you can't.
No, the 13 you can't because the size is so short, right? And
Yes.
the parent thing is right skewed.
Yes, because you're right. The parent system is right skewed, and so you can't use it because you have to have a normal probability.
And you,
Easy.
If the price n equals 36 is taken from a right cube, what is the probability that x is greater than 36.5?
Well, since n is greater than 30, we can use the normal probability. So,
Yeah. So
so
I get, I got
36.5 minus 30.
do you have the mean? Do we have the mean?
Yeah, the mean is 40.
Okay.
So
I got 0.9599.
Over
36.5 minus 40.
what's the standard deviation? Where are you seeing those numbers?
It's
Oh, I see it now.
the
Yeah.
standard deviation is
12 over square root
Oh, it's over square root of 36.
14?
Yeah. Yeah. So 6. So 30. So it's
It's 2 standard deviations.
36 point. What is that?
5 minus 40, right?
3.5. Negative
Divided.
3.5.
Uh-huh.
Because 36.5
Oh, yeah.
minus 40.
Minus 40 divided by 12
Negative 3.
divided by,
Six.
no sé cómo se diga la raíz.
Is that negative 3.5 over 2?
Yeah. So did you get negative 3.5 over 2?
Yeah,
Okay, and that equals negative 1.75.
yeah.
So then we put in negative. No, I don't want that.
And then I put this in the app.
Right.
Right. So then you use the applet and you click on the middle on the right, and it's, whoa, 0.9599.
Right, yeah.
Standard deviations.
Crazy.
Wait. Is that the answer?
Yes.
And now you are in 15?
Yes. So for 15, what is the probability that the observed is between 37.5 and 42.5? Okay.
I got 0.7887.
I believe you. All right, let's do this quiz. Down. Okay.
Now give me a minute.
Okay.
Oh, less than 6. Less than 7. No, that's less than 6.
Crazy.
Okay, using the one probability method to find the area under the standard normal curve. Just to the right of Z.
What's the z-score?
So it's the Z is 1.358.
1.358. Okay. That's 0.1745. So 0.175.
Left and right. Out of the middle.
Correct.
Um,
I wonder if I need to do 0 point.
No, okay.
Yeah. Okay. You want to read this next one, Daniela?
I am logging the page. I'm
Oh,
sorry.
sorry. Yeah, we started with that. Sorry.
We're gonna finish. You gotta hurry. We're going so fast.
don't know, but my computer is so slow today. Today is week 4. Okay.
When?
Almost.
Pretty worse.
Okay, I am ready. We are
Okay.
in. Okay, the
So,
3.
so number 1 is true. Number 2 is true. And then number 3 is 0.175.
1175.
Uh-huh.
Okay.
Okay, what do you think about number 4?
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn for a population? Will have a smaller standard deviation. The distribution of the sample means?
We'll have a smaller, yes. Right, because the distribution of the sample means is the regular standard deviation divided by the square root of the number of observations. Yep.
They're just only going to be a lot closer.
Right. Okay. Which of the following results implies that the spread x decreases as the sample size increases? Well, we just talked about, I mean, like the question before was about this. And so it's the law of large numbers.
Large numbers.
Right, meaning that the higher n is,
Yeah.
the closer together they'll be. And so n is, or the square root of n goes under the standard deviation. And that has nothing to do with normalcy of the curve. Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and standard deviation of 8.8. So that's not how it goes.
Then earn a score of 160.
So her Z-score is.
So the Z-score, she got a score of 160. So she's going to be 160 minus the mean.
Minus,
150.8.
divided by 8.
Correct. So that's the Z-score. Is that what we're looking for?
Yeah.
Yeah.
Okay, I'll put that in the calculator. 160 minus 150.8 divided by 8.8 is 1.0454545.
Yeah.
1.045.
1.0.
Because I think it says round to 2. Yeah.
Yeah, but we need
Oh,
to.
three decimal places. Okay. What is the probability that a
And then-
randomly selected student will score above 60 on the quantitative portion?
So we need to have the Z-score first and then in the app, right?
Right. So what was the Z-score again?
It's 1.045.
1.045. 0.045. So then it's 0.1480.
1.045. You get 0.1480?
Yeah.
Right. Okay. You were doing. I understand. You were doing the question before.
Ah,
You just talking about this stuff.
Right. Okay. Perfect. So for question 7, the answer is 0.148.
uh, 1, 4. Uh-huh.
Okay. Now question 8. Do you want to read question 8?
Says a random sample of 5 students was selected to take the GRE. Their scores are those. And what is the Z-score corresponding to the sample mean of these students' scores?
Okay. Let's find the mean.
All right. What is the Z-score corresponding to the sample of mean of the students?
Not times.
It's so good.
160.
Yeah. So 160 is the average.
So the Z-score of 160 is 1.045.
Did we already have that one?
Mm-hmm.
Oh yeah. 1.045.
160, what is the Z-score corresponding to the sample mean of these students?
Daniela, did you get question 8?
I am doing
Oh,
that.
sorry.
So what is the Z-score corresponding to the sample mean of the students' scores? So first we need to get the mean, right? What is 160?
Yeah. So the mean is 160, and we already figured out the Z-score for the mean of 160. You remember what it is?
And what is the standard
Oh,
deviation?
what do we
The
need
same
to
like
do?
before?
Or do we need to do the other way where you do 160 minus 150.8 over 5 divided like the standard deviation divided by the number?
8.8 divided by 5. The square root of 5.
Is that what we need to do for that one?
I don't know.
I don't feel
So-
like it would just give you the same question.
Right.
What is the standard
Right, because
deviation?
the sample mean is, or the sample is too small to be part of the regular thing.
The sample mean is
All right.
So what was your question? Sorry.
So what is the standard deviation in this one? We can do this because they. No, we can do it. So what is the standard deviation in this one?
So the
8.8.
so the standard deviation is 8.8.
Entonces I get, but I don't know if it's correct. Minus 17.61.
I don't know how you got that. Sorry. I think it should be 1.045. Remember question number 6?
In the
Look at question number 6. See that score is 160, right? So we got the mean of 160 here.
All right.
I think we need to do a little bit more. So it needs to be 160 minus 150.8. That all over 8.8 divided by the square root of 5.
All right.
So 160
So
That's crazy. I feel so bad about how bad we explain stuff. You got 2.33?
How about 2.3?
Yeah. 2.338. Oh, I should have kept that up. I'm gonna keep that up.
Not bad. Feels better.
Yeah, 160 minus 150.8 all over 8.8 divided by the square root of 5. Not really. Okay, I'm gonna show you my calculator because I think this will help.
uh,
Can you see that? Can you see that?
Almost. So I got it's 5 minus
So it's 160 minus 150.8 divided by 8.8 divided by the square root of 5.
I'm gonna write the formula.
And where do my only question is why is 150.8?
So 150.8 goes back to the beginning. See before question 6. That's where we got that from.
Oh yeah. Yeah. Okay. I got it.
Andrew wants to show you this.
That's the formula. So X is the number that they're giving you, the 160. The weird symbol next to that is the mean. And then you have your standard deviation divided by.
I was confused because I don't know. Yeah, it's the same. Yeah. Thank
I
you.
wrote it dirty, but.
Okay. Ready? So what's the answer you got for that?
Give me a minute. Then punto 8.
Yeah.
3.2 it's 2.337.
Huzzah! We put 2.338 because you have to round up.
Oh yeah.
Okay.
The probability that 5 randomly selected students will have a mean score that is greater than the achieved by the students in the previous problem.
What is the probability that the 5 randomly selected?
Okay. I think I have an idea. In the applet, 0.0097.
Why?
Why?
Yeah.
Because you're plugging in your applet.
But what? So this is just greater than any mean, greater than 150.8.
Then the students in the previous problem. So their mean was 160. So you're looking to see if you pick 5, how many of them would be.
Hold on. Okay. What is the probability that? Oh no, you're totally right. It's going to be greater than their score.
Yeah.
And does we need to use the rule about, because it's true, we need to use the rule about percentage thing?
Well, it says go to 4 decimal places, so my guess is you need this applet number.
Yeah. So I think what we're going to have to use is the applet, and you just plug in the z-score of the last question.
Yeah. Okay.
And the probability of that having to be greater,
Right.
that means having to be greater than 160.
Right.
That means it's 170.
Right. So I'm just going to put it on 2.3377070. 0.431, and it's going to round for me. 0.338, and like Andrew said, it's 0.0097.
The math was crazy.
And it knew there would be 4 decimals. You're right. Okay.
Oh, okay, give me.
Danielle, do you know what we did before? So what we did was we took the z-score and put it in the applet, but we only want how many greater than, so you go to the right side of the applet and only make blue the right side. So the middle is clear and the left is clear. And then you put in the z-score on the right side.
I'm going to mirror my screen.
Oh, no, I can't. But, so we put in the apple, the z-score is 3.993, right?
No, when you put it in, it's 2.339.
2.23.
Or 2.338, sorry. Do you see right here?
Uh-huh.
Can you, so that's the z-score that we got from the previous problem.
Yeah.
Take both of them and then actually
But so
gotta
you,
make sure they're
so but yeah, so you have to do it before, you have to, so if I click here and then I try to change it, watch this.
0.9903.
So watch what happens, just watch my screen real fast. Watch what happens when I put it in right now. So if I go 2.338, I push enter.
Uh-huh.
Look at, see, this is 0.0194. But watch what, and then watch what happens when I clear this. See how it goes down? I didn't have to do it before, like I usually do.
Yeah. I think
0.0097.
Correct.
Okay. Bye.
¿Te puedes pasar de este lado para que no me vea yo en la cámara?
Normal.
0.97.
Did you do 10?
Mhm. Okay, we are in the 7th. Bye. Thank you.
The distribution. Making sense to me.
I shouldn't say that.
The next one, the 10 is approximately normal, right?
Right.
Yes.
No.
And Joe says what's 11.
What is the mean of the distribution of the sample means for all possible samples?
Oh, it's just like the average distance. Because in parentheses it says sampling distribution.
Yeah. So you want to give me like can you just throw this in the other one and just drop it?
For all possible, I think. Ooh, good question.
For all possible samples, it's like anyone. What is the meaning of the distribution of samples?
That could be drawn. Do you know how to do this one, Daniela?
I think we only need to. How do you say this word? Yeah, I need to find the word. Isolate. The mean, right? Of the z-score. The z-score formula. We need to isolate the mean.
Oh, that would make sense. So you just take. Do you go x minus 150.8.
But how do you find the z-score?
Yeah,
There isn't a number that we can find the z-score.
Because you have the mean. Well, no, suppose the mean GPA of BYU Idaho students is 3.5.
oh, it's farther up is the instructions.
So it's 3.5. That is the answer.
Okay.
3.5. That is because it's the same answer for.
Okay.
And what is the standard deviation of the distribution of the sample means?
So one second. So for the one before, it's the same. It's 3.5. It's the same as the parent function or the parent, graph because it's higher than 30. It's close enough. Okay, you're right. You killed it. Okay.
And the other one is we need to make the standard deviation divided by the number, right? By the size, I'm sorry. By the...
Right, so it's going to be 0.7 divided by the square root of 81, which is 9.
0.7 divided by 9. That's really high.
What do you mean it's really high?
0.7 divided by 9.
That's 0.07. I think you're thinking 0.7 divided by 0.9 would be. So
round the 3 decimal places.
Well, hold on, because
you get 0.07.
Okay, 0.078.
8.
Okay, and then man, there's a lot of questions. 13.
Yeah,
what is the probability that the mean GPA of 81 randomly selected BYU students will be less than 3.3? So what was the mean? 3.5 was the
minus 3.5 over 0.7 divided by 9.
got negative 2.57. That seems crazy though. It's not that hard to be less than 3.3.
Give me a minute.
That's crazy. It's got to be like a standard deviation, so it's got to be like 1, 2, no higher than 3. Okay, I have negative 2.57, so you're close.
2.57?
Yeah.
So what did I do wrong?
I don't know. So 33, so it's 3.3 minus 3.5 divided by 0.7 over 9. Well, then you put it in your computer wrong, because I did it as one step.
Okay, yeah. And that's what you got negative.
I got negative 2.6, but that's crazy talk.
Not necessarily.
I guess because this.
Yeah, negative 2.6. I get to.
You said negative 2.6?
Negative
Negative 2.597.
Okay.
Negative 2.6, so it's 0.0047 probability.
Zero point zero 0.05. 0.005. Yeah, 0.005.
Zero 0.005.
Okay, what is the probability that the mean GPA of 81 randomly selected BYU students will be greater? 1 minus that. 1 minus 0.005. 0.995.
19. What?
It's 0.995.
Oh yeah.
Because it's 1 minus the answer we did. before?
Mhm.
Because the
Second rule,
rules.
the rules of probability. Yeah. Okay. United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. Huh?
That's pretty high.
Yeah. Well, yeah, that's.
But to me, I mean,
You got to have like 400 pounders in there. Yeah. Okay. The previous the previous value was lower, but was raised after the fact. This is terrible. I'm sorry. Sorry, Brother Fox, for laughing about that. The standard deviation of passenger weights is 26.7 pounds. Okay. The weight of a random sample. I'm losing it.
The weight of a random sample of 48 passengers were recorded. The sample mean was determined to be 177.6 pounds. On the probability that a random sample of passengers will have a weight that is
As
as extreme or more extreme.
So it's just 177.6. So 177.6 minus 185 divided by the standard deviation, which
Either
is
above or below.
27.
Well, the percentage of finding them above or below is 100%.
Probability there. No, not. Oh, that was absurd.
Is that
Well, no,
more
it's not 100% because it's on the outsides of this anything between 177.6 and then however far away. No, and then past that to the outsides. So like, hold on, let's find the z-score for that.
So weights of
Divided by 27
the sample
point,
mean is determined 177.6.
26.7.
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean.
So it's
Oh, okay.
177.6 minus
Minus
Right, minus 185.
However, standard
Uh-huh.
deviation of 26.7 divided by the square root
26.7.
of 48.
Divided by the square root of 48.
Okay?
Uh-huh.
Negative 1.92. So that's our z-score. So negative 1.92. So, and then you trade in both sides. 0.0549.
Ay, no, a ver.
So 0.055. All right, I'll submit mine. Say that again.
0.055, you say that?
Yes. Submitting.
Mhm.
I'm not as confident in this one as I was the other ones.
I'm pretty confident in this one.
Okay, good. We're good.
Nice. What question is
100%.
Yeah?
Yes.
Woohoo!
Let's make sure everybody gets 100 so we got all the right answer, all the same answers.
yeah, man.
Did you get 100?
Yeah, I need to save it. But my computer is so slow. So,
Darn it.
Sure, I have one psychology. It's on Tourette's.
Cool.
So I have to write a 10-page paper for Tourette's.
That's extensive.
It's pretty
Yeah. I haven't had to write any big book papers yet either.
I'm doing one.
You did.
That freaking one last semester was so garbage. After that, I just hate it. Like you have too much evidence. Well, you know what? Forget you too. Okay. How can
You don't
how can
have,
you have too much?
because you don't have enough of your voice in it.
But then like super
Yeah.
idea. And to have enough ideas to get 10 pages. Yeah.
yeah, I got 100.
Excellent. Okay. Well, then we will see you next week.
Okay. Yeah.
Okay.
Thank you.
See ya.
Bye.